Section 1.2, functions and graphs. A little bit about the definition of a function. You can find it on page 78. It says a relation that's a correspondence between the first set, called the domain, the second set, called the range, such that each member of the range corresponds to at least one member of the range. So if I have, for example, if my data set is 9, -5, 9, 5, and 2, 4. I would go ahead and I would make a table. And this table that I'm going to make is actually called a mapping. And don't let me forget my set brackets are in this. So I have 9 and 2. Those go in my domain. This is my domain. Okay, I don't write 9 2 times when I make a mapping. 9 and 2, and I'll write mapping here. My range is -5, 5, and 4. My domain, 9, goes to both of these numbers, and 2 only goes to 4. Okay, the question that they're going to ask us, is this or is this not a function? The answer for this one is not a function because, whoops, I can't spell function, because 9 goes to 2 numbers. So I'm going to write because 9 goes to 5 and -5. Okay, another data set example. If I have -2, 5, in parentheses, 5, 7, 0, 1, and 4, -2. End of set. So what I'm going to do is I have, it looks like I have -2, 5, 0, and 4. So -2, oops, 5, 0, 4. Doesn't really matter what order you write them in. Okay, and then for my range, I have 5, 7, 1, and -2. So -2 goes to 5, 0 goes to 1, because I accidentally wrote them in the wrong order, and 5 goes to 7, and 4 goes to -2. Okay, so this, everything is going to its own individual element in the range. Each number that I have in each circled would be an element. So this is an element of the domain. 5, 7, 1, and 2 are elements of the range. Okay, if I ever accidentally write it, I'll try not to, but it would look like 5 is an element of the range. -2 is an element of the domain. It's kind of like an E-shaped thing. So that is a function. You could probably just write yes for your answer. Okay, so we don't have to write more than that when it is. The next example, if I have the set of numbers that include -5, 3, 0, 3, and 6, 3. End of set. What this is going to look like is I will have in my domain, I will have the elements -5, 0, and 6. In my range, I will have 3. I only list each number once. I could list 3, 3, 3, but that's not really going to show us what we want to look at when we look at these mappings. They all actually go to 3, and this is a function. Yes, it's a function. Okay, the only time I'm going to have something that doesn't look like a function is right here on this 9 going to 2 different numbers. Okay, but 3 different numbers can go to the same one in the range as long as it's not a different one coming to from the domain. hopefully you guys have heard of the vertical line test. If I were, usually I have some sort of line, and then I try to test where two lines go through things. Oops, there, well, that line still. So if I were to do that, I would have 2 here. So I have 2, 4, 6, 8, 9, not that that really matters. At 2, I would go up to 4. At 9, I would go up to 5, and I'd also come way down here to -5. And you can test and see that I have this one line going through 2 points. So it doesn't pass what's called the vertical line test. So the vertical line test, can't spell line. Okay, and the vertical line test just says that I can't have a line go through more than 1 point at a time. Okay, and then we also have function notation. So function notation is read f of x. So if I say f of x, I want f begin parentheses, x in parentheses. That's read f of x. So f of x, this is just for the example, f of x is equal to x squared minus 9x minus 12. And this example is on page 79. So what we use function notation for is so that we can actually plug things into it. And that way I can actually remember what I'm plugging into it as I go along. So I would have -2, plugging in this -2 everywhere I see an x. Make sure that I'm putting it in parentheses. That'll really screw you up. A lot of people, I don't know about you guys, will just do -2 squared and they'll just type that in their calculator. If I don't do parentheses, I'm going to get -4 instead of +4. Because -2 times -2 is +4. Is that 12? Okay, when you guys were younger, I don't think you guys will still do it anymore. You guys might do it a little bit. We would have like -2, we would make an x, y chart. Y just represents what we have here for f of x. So all along I'm going to write f of -2, and I'm just going to simplify down this whole side. So I'm going to have 4 plus 18 minus 12. When I add all those things together, I'm going to get -20. So I'm going to write f of -2 equals 20, where before I would have to write out all my stuff here on my xy table, and then I would just have -20 when I'd get done. So we don't really make the xy tables anymore. We'll just list out f of whatever numbers we have. F of 0 always tells us the y-intercept. So remember, the y-intercept is where it crosses this vertical line. So f of 0, I'm going to have 0 squared minus 9 times 0 minus 12. So if I'm ever looking for that y-intercept, I know right now when I simplify that, f of 0 equals -12. So whatever this graph is going to get me, I know I'm going to go through the line at -12. And I'll go through and actually make a better graph. So when you're actually going through to graph things, I want to make sure that you guys are actually plugging in these points and finding them instead of using them just on the calculator, because you guys probably already know how to use them in the calculator. So then I also do f of 1. I always think in order to graph something decently, I always need about 5 points, unless it's linear. Then you can just do 2. But this is a quadratic because I have x squared. So I need to do 5 points. So far I have f of 0, f of -2, and then I'm going to work on f of 1. So f of 1, I will have 1 squared. Since this is positive, I don't really need to worry about writing parentheses around it. Minus 9 times 1 minus 12. So f of 1 will be 1 minus 9 minus 12. So that will be minus 22. Just kidding, because it's a positive 1. So that'll be minus 20. Okay, because that'll give us -21 plus 1. So -20. Hopefully you guys take notes in pencil, right? I can go ahead and graph each point as I go along. So if I do -2, so let's count by 2's on this axis. So 2, 4, 6, 8, those are negatives. And +2, 4, 6, 8. So far, since I have some -20's, I want to make sure... Boy, I'm really sorry. I wasn't paying good attention going up here for the f of -2. I was just looking in the book and I picked out the wrong thing. So this is actually +10. So maybe I should actually do the math in my head. So f of -2, I'm going to go up to 10. We're going to count by 5's because these... Oh, my pen sheet. Okay, so we're counting by 5's. So 15, 20, 5, 10, 15, 20. Okay, what I always tell my students to do, the 5 points to pick for a quadratic equation, I tell them to pick f of -2, so we already have that, f of -1, 0, 1, and then f of +2. So I like those 5 points. Those usually give us a pretty good spread of our points. So f of -1, since it's negative, I need to make sure I'm writing parentheses. I have no idea why it's shaking so bad. So I just have the shake, you know. Okay, minus 12. Okay, so -1 squared is +1. -9 times -1 is +9. Minus 12. So f of -1. So I'll have 1 plus 9 is 10 minus 12 is -2. And then we're also going to do f of 2. And another way to think about the f of -1, think about it as f at -1. What's happening of the function, which is named f, at my x value of -1? And what's happening is my y value, which is my output. So f of 2, to finish this, I have 2 squared minus 9 times 2 minus 12. So I have 4 minus 18 minus 12. -18 and -12 is going to give me -30. -30 plus 4 will be -26. So I'm also going to need my 25, so negatives. Okay, so at f of -2, I have 10. So at -2, I have +10. I'm sorry, +10. And at f of 0, I have 12. At 1, so this is right here, I have -20. At 2, I have -26. So what point did I miss? -1, so at -1 I have -2. Okay, this kind of looks like a straight line just because I don't actually have 5 really good points. But I'm going to try to connect them as best that I can. And then just always remember that quadratic functions come back up, or they go the other direction. I still don't know why my thing is shaking, so it looks awful. But you'll have a graph that looks about like that. Okay, I'm not too worried about it. I'd rather see these 5 points than I would have you have the parabola exact and you just typed in your calculator. Okay, just real quick to test if something's a function, we can take any vertical line, and of course I have a terrible drawing, so of course I have more than one, but I can make vertical lines anywhere that I need to, and maybe I can make vertical lines. And this never crosses the graph more than one time. It's always just once, so this is a function. Another example of just plugging things into the function. If I give you f of x, oops, I guess I get blue. F of x equals 2x squared minus x plus 3. And I'm going to ask you, so this is maybe what the question would be, is to find f of 5a. What I'm going to do, I'm going to plug 5a inside parentheses everywhere I see an x. So I'm going to have 2. Instead of x, I'm replacing that x with a 5a squared minus 5a plus 3. I like to think about it as every x I have, I go through and put parentheses around the x and only the x. Wherever those parentheses are, that's where I'm plugging stuff in at. Okay, 2 times 5a squared. 5 squared is 25. A squared is a squared minus 5a plus 3. Really doesn't get more simple than that, so I have f of 5a. So I will have 50 a squared minus 5a plus 3. Those ones really aren't that bad. A lot of times I get people messing up when I give you something like f of a minus 4. Okay, this gets nasty when we actually have quadratics. So instead of x, now I'm writing a minus 4 squared minus, instead of x, I have a minus 4 again, plus 3. Remember that I can't just do a squared minus 16, as nice as that would be. I have to go off to the side and square a minus 4. Hopefully you guys remember your rules well enough that you can just do 2. And then in parentheses, I'll have a squared minus 8a plus 16. I'm hoping you guys can remember those rules. Then I'm going to distribute this negative sign throughout. A lot of times when I have minus, I have people forgetting which signs to use. So I have negative a, and a negative times a negative 4 will be plus 4. And then I have plus 3 hanging on at the end there. Okay, I also have people a lot of times forget about 3's as my constant, so you just leave off their constant terms. Okay, I still need to distribute that 2 throughout these parentheses. So I will have 2a squared minus 16a plus 32 minus a plus, I'm going to go ahead and add those in plus 7. Then I don't have any other a squared, so I have 2a squared. 16, I have negative 16 and negative a. That will give me negative 17a. Then I have 32 and 7. That will give me 39. Since that is as simple as it gets, I can't add these guys together. On my final line for my answer, I'm going to have f of a minus 4 in parentheses equals 2a squared. So I don't care if you don't write the f of a minus 4 on each line, but I do want it on the first line and the last line. There will be a lot of graphs that you'll actually have to plug stuff in that are not necessarily quadratic functions. For example, I'll have f of x equals the square root of x plus 4. Okay, when you do square roots, just go ahead and start at whatever this number is, the negative of that. So I'm going to have f of negative 4. Okay, and my square root sign, I have negative 4 plus 4. So f of negative 4 is the square root of 0, which is 0. So then go ahead and give me still 5 numbers. So f of negative 3, I want you to go towards the positive direction. The square root of negative 3 plus 4. If you guys want to work out in a line, you can work out in a line. That's the square root of 1. Square root of 1 is 1. Okay, I want you to do the first 2 numbers can touch each other, like negative 4, negative 3, they're consecutive numbers. After that, I don't really care. 0 is always a nice one to plug in, or hopefully always a nice one to plug in. I can't promise. 0 plus 4. The square root of 0 plus 4 is the square root of 4, which is 2. Okay, f of 1. Square root of 1 plus 4, that's the square root of 5. And I will go ahead and estimate that. So the square root of 5 is about 2.23, if I can get my pen. So when I go ahead and I graph that, I think I don't have 5 points yet, so I'll do one more point. Okay, so I will have, let's call this 0, 0, 1, 2, 3, negative 4. So at negative 4, my y value is 0. At negative 3, my y value, let's 1, 2, 3, that'll be 1. At 0, I have it 2. And then at 1, I have 2.23. And actually, probably 3 or 4 points would be good for a square root function. I'm not very good at drawing these either. If you actually notice it, it is actually basically a square root function on its side. So if we were to do that, I could have something and it would look more like a parabola. So a square root function is a quadratic function on its side, but we only do half of it. And then we'll check with the vertical line test to make sure that they actually work for vertical lines, and it does. If you look on page 84 and 85, they have some really nice examples of how to do domain and range that I really like. So for example, they have, just a linear function on page 84. So what this represents, what they actually have written out, is, hey, it goes left and right forever. So they have that colored red. It'll go up and down forever. So they have that one colored blue. And they're doing those intervals in red and blue. So in this case, a domain would be all reals. So you'll just write, instead of spelling out reals, you can spell out reals if you want to. I use my fancy R sign. My range, can't forget what letter I'm writing, will also be all reals because I didn't have any breaks up and down. I didn't have any breaks left and right, so that was my domain. Okay, and then for B, they have a square root function. And so they have the interval. So your interval is actually going to be right here. This will be included, so it would be like what we usually see as a solid dot. They use a square bracket. I kind of like how they use a square bracket, and then it goes right from forever from there. Okay. Going up and down, and just try to do these intervals on the axes. So go ahead and graph them and then do them. And then I'll try to pick a different color. So up and down, it starts right here. That's not a very good color. So it starts right here at 0, and it'll go up forever. So that's going to be a square bracket, because 0 will be included, because the square root of 0 is 0. So always include it right at that line for square root functions. So the domain, so if we use the interval notation, which will be easiest, since they told us it started at -4, since my picture's not very good, it will be a square bracket at -4. My computer must be having a spasm. -4. And since it goes right forever, it will go to positive infinity. Infinities always have a parentheses. My range, since it starts at 0, it will go up. So up will be to positive infinity. 0, infinities always have parentheses, and 0 is included, so I have a square bracket. Okay, the next one they have for C is a cubic function. Cubics go left and right forever. They also go up and down forever, so everything will be included. Then for D, they have a rational function. And they have 1 over x minus 2. So what they have is something that looks like this. Okay, whenever we hopefully learned about asymptotes, we will cover these a little bit more. Right now we're just going to be looking at pictures. Just remember that there's an asymptote here, that these are never going to cross. Same thing that this intercept right here is also an asymptote. So I will have my intervals, they set it up that at asymptotes, since I never cross it, I'll never actually have that function value. So it will not include that function value. So it's basically everything here, everything here. So you might want to say all real numbers, but there's one number, and in this case, if you look at the picture, it's actually at 2. 2 is not included in the domain. So domains are left and right, and 2 is not included, so it's everything from the left. So from the left is negative infinity. And then at 2, 2 is what I'm going to say, since it's not included, I'm just going to use a parentheses, and that really means negative infinity all the way up to everything up to 2, but not including 2. But since it starts back again at 2 and goes back to positive infinity, I'm going to write the union in between it because there's really two things that happen. So it goes left forever, it goes right forever, but nothing right there. Okay, so we used to think of that basically as an open dot. So that open dot, we have a union. Okay, the same thing is going to happen for up and down. Okay, so this is going to happen at 0. So I'm going to have an open dot at 0 in my left up and down. So I have a parentheses here and here. Go down forever, go up forever. So my range, instead of 2, I will have zeros in there. Union, 0 to positive infinity. Okay, and then they have some examples of things that, oops, I really want a solid line. Ah, my stuff stopped working. Okay, so this is my next axis. I have a circle, half a circle. Okay, so my domain will only be from here to here. So if you look at it on page 85, this is 1 and this is 5. So my domain, since it will be included, it is 1 to 5 in square brackets. In my range, my highest value, if you look at it, is 2. My lowest value is 0. So my range will also be in square brackets, and it will be from 0 to 2. Make sure we're always listing the lower number on the left-hand side. So for your homework on page 86, from 1 through 6, tell me one yes and one no. Pick one yes and one no. So they're just yes and no answers. They're just picking whether or not it's a function. And then I want you to do numbers 12 through, I want you to do 12 through 90 by threes.